Now we'll discuss about the bonding and geometry of molecules. So we have so many theories to explain the bonding in bonding as well as the geometry of the molecules. And here we'll discuss about the Vsepr theory called valence shell electron pair repulsion theory. And this theory actually predicts the geometry of a molecule. That means around, if you take a molecule, say for example methane, there will be a central atom. For example, in methane, carbon. And around the central atom, there will be certain electron pairs. And those electron pairs in space will arrange with respect to the central atom in a specific manner. Okay. അതായത് ഇപ്പോൾ നമുക്ക് മീഥെയിൻ തന്നെ ഒരു എക്സാമ്പിൾ എടുത്തു കഴിഞ്ഞാൽ അവിടെ മീഥെയിനിലെ സെൻട്രൽ ആറ്റം കാർബൺ ആണ്. അപ്പോൾ കാർബണ് ചുറ്റും 4 ഇലക്ട്രോൺ പെയറുകളുണ്ട്. നമുക്കത് പിന്നീട് പഠിക്കാം. ആ 4 ഇലക്ട്രോൺ പെയറുകൾ നിങ്ങൾ ബുക്കിൽ എഴുതുന്ന പോലെയല്ല, സ്പേസിലാണ്. സ്പേസ് പറഞ്ഞാൽ 3 ഡയമെൻഷണൽ സ്പേസിലാണ്. ആ 3 ഡയമെൻഷണൽ സ്പേസിൽ ദീസ് 4 ഇലക്ട്രോൺ പെയർസ് വിൽ അറേഞ്ച് in a specific manner. The ultimate aim is to minimize the repulsion between the electron pairs. Because electron pair തമ്മിലുള്ള repulsion കുറഞ്ഞാൽ potential energy കുറയും. അപ്പോൾ ആ സിസ്റ്റം സ്റ്റേബിൾ ആവും. അങ്ങനെ ഡിഫറെൻറ്റ് ഡയറക്ഷനിൽ സ്പേസിൽ ഓറിയൻറ്റ് ചെയ്യുമ്പോൾ the molecules will get a definite geometry. This is the basic idea of valence shell electron pair repulsion theory. Okay, so actually the theory was proposed by Sidgwick and Powell, and it was developed by Gillespie and Nylon. Based on that polyatomic molecule, the bonds will arrange around the central atom. Okay, and we will discuss those points later. And the shape of the molecule is determined by the repulsion between all of the electron present, and electron pairs in the valence shell of the central atom. I told you all these, and we have 2 types of electron pair called a bond pair and lone pair. Bond pair means those which involve in the bonding is called a bond pair. Lone pairs are those which do not involve in the bonding or called bond pairs. Now, usually the repulsion is maximum between 2 lone pairs, and then the extent of repulsion is more for lone pair, bond pair, then least for bond pair and bond pair. This is the extent or the strength of repulsion actually. Now here we will discuss about the shape of molecules containing bonded pair of electrons only. So after the formation of a molecule, suppose you have only the bond pairs, and there will be the case around the central atom there will be both bond pair and lone pairs. And we'll come to that point later. Now we'll discuss only about the bonded pair of electrons. So the first case is central atom with the 2 electron pairs. See, a typical example is beryllium. Suppose you taken the beryllium, then the valence shell is 2s which contain 2 electrons. There are 2 electrons. Now what happens is, if there are 2 electrons of the beryllium, and each hydrogen whenever it is bonded, so it will contribute 1 electron. So here you have 1 electron pair. Here also you have 1 electron pair, and both are involved in the bonding, so they are called a bonded electron pair. So you have 2 electron pair, precisely bonded pair of electron around the central atom. So what happened? So this dash actually contains a pair of electron, bonded pair of electron. Here also we have a bonded pair of electrons. So how they arrange in space? They arrange it at 180 degree so that the repulsion will be minimum. So you can say the geometry will be linear. So it is not only for beryllium dihydride, for all those molecules where you have 2 bonded pair of electron around the central atom will have linear arrangement at 180 degree. There is no doubt, because that will have minimum repulsion. Now we'll come to the next one, central atom with the 3 electron pairs. There are 3 electron pairs Say for example, if you take a BF3 molecule, BF3, then you can see there are 3 electron pairs, and all the 3 electron pairs are bond pairs. So here you have a bond, 1 electron pair, the second bonded electron pair, third bonded electron pair. So there are 3 bonded electron pairs. In space, they arranged at a 120 degree. 120 degree. So, and what is the geometry? It is trigonal planar. Clear? So all those molecules where there are 3 electron pairs and all are bonded pairs around the central atom, we have trigonal planar geometry with a 120 degree as the bond angle. Now we come to the next case. Suppose you have a central atom with 4 electron pairs, then what happens? There are 4 electron pairs. You are familiar with this geometry, and they are arranged in a tetrahedral manner. Tetrahedral manner. So this bond and this bond are on the plane of the paper, this one and this one, and this is away from the viewer and this is towards the viewer. So that's shown here, and the bond, and the bond angle will be 109.5 degree. There is a bond angle. The geometry is called a tetrahedral. Now if you have a molecule with 5 electron pairs and all are bonded electron pairs, and then this is the arrangement. Out of the 5, 3 are arranged in a plane. These are the 3. So here the picture is much more clear. 1, 2, 3. These are arranged in one plane. This is above the plane and this is below the plane. And if it is arranged in this manner, then what is the geometry called a trigonal bipyramidal? You can see. So here there is what is so called a pyramid with a triangle as a base, isn't it? You look on to the upper part. If you take on the upper part, there is a pyramid with a triangle as a base, and you have the same which are one more such a pyramid, trigonal pyramid. So there are 2 trigonal pyramids. That's why it is called trigonal bipyramid. Now what are the bond angles? So here the bond angle in this plane is 120, and these bonds are called equatorial bonds. This one, all these 3 which are on this plane is called equatorial bond. All these are called axial bond. The equatorial to equatorial bond angle is 120, while the axial to equatorial bond angle is 90 only. So there are 2 different bond angles in this molecule called a trigonal bipyramid. Now, if you have an atom, a molecule with 6 electron pairs, and the arrangement will be like this. Out of the 6, the 4 are arranged in one plane, and one is above the plane, the other one is below the plane, and all are having same bond angle called 90 degree, and the geometry is called octahedral. Octahedral is the geometry. So these are the different geometry of the molecule. They contain only the bonded pair of electrons. Now we continue with the molecule having both bond pair and bond pair in the next session.